Welcome to helpyourmath.com. Today we will be learning how to solve for x using reference formulas that I placed right here, the difference of two squares. I'll get into this in just a second. First, let's begin with the problem. So here we have 2x squared equals 50. Our first step is to move over the 50 to the left side of the equation so we can have everything on one side, and then we're going to factor what we have left. First by using the GCF, and then our special reference formula of the difference of two squares. So here we go. So first we're going to take the 50 from the right side of the equation and we're going to move it over, transpose it by using the additive inverse. We'll subtract 50 to both sides. And here these two 50s will add up to 0. And on the left hand side we'll have 2x squared minus 50. Now we have a quadratic equation, and so our goal here is then going to be to take the greatest common factor out of both so we can just have an x term, an x squared term actually. So by factoring out the 2 here, we're going to have a 2 come outside, and on the inside we're thinking what's left over when we factor out the 2. So for the first term we're just going to have x squared, and to make 50 with a 2 we just need a 25. So here we have a difference of two squares, right, which is our reference formula. Here we see that a squared minus b squared gives us the product of a minus b times a plus b. In our case, we have x squared minus 25. So here, if we see we have x squared minus 25, our first step is going to be to find the perfect squares in each term. Now, x squared is already a perfect term, so here we could just put x to the second power, and the number that gives us 25 is going to be 5 squared. Now, once we have the two factors factored out, all we have to do is use this formula as a guideline to set up the next factoring step. So our first term for a will be an x. So in the first set of parentheses, we're going to have x minus 5. And in our second set of parentheses, we're going to have x plus 5, where our b term is valued at 5 and our a term is valued at a. If we look directly under each, they are matching compatibly. And so what we have left here on this side is going to be 2 times x minus 5, x plus 5. And this is equivalent to 0. Now in the next step, what we want to do is solve for each factor as we set them equal to 0. So we'll set each factor equal to 0, and this 2 we can just leave here, as 2 can never equal 0. We set the next ones, x minus 5 equal to 0, and x plus 5 equal to 0. We don't have to worry about this as there's no solution for this. However, we're just going to move over the 5 by adding it to both sides. These two cancel out and we have x equals positive 5. And on this one we're going to have x plus 5 equals 0, so we're going to subtract 5 to both sides. These cancel out and we're left with x equals negative 5. And here we have our two solutions to the problem. X is positive 5 and x is negative 5.